Welcome to MathMaster. Today, you're on your journey to discover a pattern and hence a rule for the algebraic identity a plus b plus c the whole square. Today, you're provided with a lab observation sheet, 3 purple squares, 3 green squares, 3 blue squares, 6 brown rectangles, 6 orange rectangles and 6 pink rectangles. Let us consider the side of the purple square to be A. What is its area? Is it not A square? Write it in the space provided in the square itself. Let the side of the green square be B. What is its area? Is it not B square? Write it in the space provided on the square itself. Let the side of the blue square be C. What is its area? Is it not C square? Write it in the space provided on the square itself. Now, compare the length and breadth of the brown rectangle with the sides of the purple and the green squares. Can you identify its length as A and breadth as B? Note the area of the rectangle on the rectangle itself as A into B. Now, compare the length and breadth of the pink rectangle with the sides of the green and the blue square. What is its length? Is it not B? Can you identify its breadth as C? Note its area on the rectangle itself. Now, compare the length and breadth of your orange rectangle with the purple and the blue squares. Is its length A and breadth C? Note its area on the rectangle itself. If you look carefully at your lab observation sheet, there is a picture of a square. Now using 1 purple, 1 green and 1 blue square and 2 brown rectangles, 2 orange rectangles and 2 green rectangles make the white square. So right here I have assembled my squares and rectangles to fit exactly into the white square. I have also noted the individual length and breadths. Can you identify the length of your white square? Is it not A plus B plus C? What is its area? Is it not A plus B plus C the whole square? Now, note the area of the individual squares and rectangles in your model. Is A plus B plus C the whole square the sum of the individual squares and rectangles in your model? Can I say that A plus B plus C the whole square is nothing but A square plus B square plus C square, that is the area of the 3 squares plus the area of the 2 brown rectangles as 2AB plus the area of the 2 pink rectangles as 2BC plus the area of the 2 orange rectangles as 2AC. So right here I have written A plus B plus C the whole square is A square plus B square plus C square plus 2AB plus 2BC plus 2CA. It can also be written as A square plus B square plus C square plus 2 times AB plus BC plus CA, removing 2 as it is common to the last 3 terms. Now, how do we solve problems if either A or B or C is negative? Let us consider A minus B plus C the whole square. So, we will write b as plus of minus b in a bracket itself and solve as we solved the previous case. So right here I have put b in a bracket so that I maintain it as a negative term completely in a bracket. We know that neither area nor length can be negative. However, in order to arrive at a pattern, we will keep the negative signs in brackets. Now, note the individual areas of your squares and rectangles. Wherever we find minus b in a bracket, you can shade that picture or hash it. Right here we have done. Wherever we have negatives, we are going to hash it so that we remember these values will have a minus sign. Now, can we note the individual areas of our squares and rectangles? Remember, the square of a negative number is always positive. Therefore, the three squares will never get hashed. So, we can say a minus b plus c the whole square is nothing but a square plus b square plus c square. Now, look at the two round rectangles. We have minus 2ab. Look at the two pink rectangles, minus 2bc. Remember, we had hashed them. And look at the two orange rectangles, plus 2ac. Right here, we have written a minus b plus c the whole square as a square plus b square plus c square minus 2ab minus 2bc plus 2ac. What happens when you see two negative signs? If b and c are negative. Remember, minus into minus is always positive. Have fun discovering a pattern and hence a rule for the algebraic identity a plus b plus c the whole square.